Today we're going to be talking about vectors, specifically projection of u onto v. Let u and v be non-zero vectors, and then there's some component vectors, w1 and w2, such that w1 is known as the projection vector. It is the parallel vector to vector v shown. Then vector w1 is called the projection vector of u onto v, denoted as this. This is how we find it. Here's a proof of how it works. Not really important, but it's there if you need it. So it says find the projection of u, 3, 2, onto v, 5, negative 5. Then write u as the sum of two orthogonal vectors, one of which is the projection of u onto v. So we look at that equation that we just had, the projection equation. Okay? And it was written like this. The dot product of u and v times the magnitude of v squared times my vector v. So if I set this up, the dot product of u and v would be 3, 2, dot 5, negative 5, and then the component 5, negative 5, that projection squared, then obviously we'd have to multiply it by v again. So, dot product, okay, 3 times 5 plus 2 times negative 5 all over square root of 5 squared plus negative 5 squared, squared. So 3 times 5 is 15 plus 2 times negative 5 is negative 10 all over 5 squared is 25 plus 25 is 50. Square root of that squared is just going to be 50. And so I get 5 over 50 times my vector, which is 5, negative 5. Well, 5 over 50 obviously reduces to 1/10. So 5 times 1/10 would be 5/10. And negative 5/10, well, that goes even farther, as into 1/2, negative 1/2. So what did we just find? We found the projection vector 1/2, negative 1/2, which is the projection of u onto v. So essentially we found this little one right here. So the second part they're asking us to find is what's the rest of the line right there to make up v. So we would say that, okay, well, 1/2 plus negative 1/2 plus some vector a v would have to add up to 5, negative 5. And so what they're asking us to find is what is a and b right here. Okay, well, easy enough problem. If we took 5 minus 1/2, that would be 4.5. And negative 5 minus a negative 1/2 would be a negative 4.5. So if we wanted to write, the original question had us write u as the sum of two orthogonal vectors, it would be this. U then would be equal to 1/2, negative 1/2, plus 4.5, negative 4.5. So, projection vector, sum of two orthogonal vectors. So let's take another look at an example, but this time our projection vector is in the opposite direction of v. So first we need to find our projection vector, which is the dot product of u and v over the magnitude of v squared, then times my vector v. Okay? So first the dot product would be 4 times 2 plus negative 3 times 6 all over the square root of 2 squared plus 6 squared, that quantity squared, then times my vector v, which is 2, 6. Okay, simplify as much as we can. 4 times 2 is 8, plus 3 times negative 6 is negative 18, all over 2 squared is 4, 6 squared is 36, I get the square root of 40 squared, which is 40. So 8 plus negative 18 is negative 10 over 40, negative 1/4, times my vector 2, 6. Multiply the scalar multiplication. Negative 1/4 times 2 would be negative 1/2. Negative 1/4 times 6 would be negative 3/2. Okay? So now we know our projection vector. That's this one right here. So now we need to figure out the next part of u. So what I'm going to do is I'm going to say, okay, well, u is this amount right here, right? So u is going to be 4, negative 3, and it's going to be equal to negative 1/2, negative 3/2, plus some other vector a, b. So let's figure out what that AB vector is. Okay, well, the way we do it is we take 4 minus negative 1/2 would be 4 1/2. Negative 3 minus 3/2 would be negative 1.5. So our projection vector is this, and our sum of u is going to be negative 1/2, 3/2, plus the vector 4.5, negative 1.5. There's another example right there in the guided practice. Feel free to try that one. Now,